Hey guys, it's your boy Hyper110, and today we're going to be doing a diffraction experiment for my physics class. Also, I'm recording this over Thanksgiving break, so I hope you guys have a wonderful holiday, stay safe, and I hope you guys are as full as an electron orbital. So before I begin today's lab, I first need to explain to you guys what a CD is. Now, back when we were all in our mom's womb, basically, people used this circular device that stores information. They put it into a machine that reads that information and displays it on a screen. Honestly, I don't know how people survived during that horrendous time. Getting to the point, on the back of these CDs are grooves that store the information onto the disk, and using the principles of optics that we've learned in class, it could act as a diffracting gradient if we shine light onto it. And then, we use a bunch of other formulas, and from what we know on a macroscopic scale, we can determine the distance between each groove. I was fortunate enough to predict that this lab was coming, because back when I was in a junior year of high school, I ran for a position in my school government, and I bought a lot of CDs because I wanted to treat them as mixtapes and pass them out to the student and be like, yo, vote for me, have a mixtape. Vote for me, have a mixtape. Looking at these CDs is kind of like walking down memory lane because for some reason I wrote the pressure formula as F equals AP because that's how I felt like AP classes back then. I literally just said have my mixtape in this one. For some reason I have the chain rule on this CD. And then I have something about chemistry here. And then I have the half angle for tangent. I don't know. High school is a weird time. So in order to do this lab experiment, I also need to make kind of like an aperture, a setup, in order to calculate the distance between the CD grooves. And so basically I kind of need a screen to hold up the CD on one end. I also need the screen on the other end where I can have the light source and also a wall where the reflecting light will hit and display a variable that we need to solve for in this equation. So I woke up this morning and I found some expired cereal. So I ate it all and turned the cereal box into an aperture that I can use for this lab experiment. I have my CD stuck on one end, and on this end, I used the expired cereal, which was hard as a rock, to stab a hole where the light source can penetrate through onto the CD and reflect back onto its own side, where I can then measure the distance between two of the maximums. And I'm going to be doing that by sticking these paper that I cut out to fit onto there. And I can put one in for one trial, this for next trial, and this for a third trial. And now, if you happen to be a close friend of mine in high school, you're probably wondering, Hui, back when you're in my lab group, you only did the experiment once. Then you would change the answer 2 times and submit it all. What happened to you? And to that, I would say, college changes you. It makes you into a better person. That, and also my dad accidentally bought 3 different laser pointers with different wavelengths. And so I'm a pretty frugal person, immigrant grind, first generation, whatever. I might as well use all of them so they don't go to waste.
It is strongly recommended that you wear clothing that completely covers your arms, torso, and legs.
So I heard that in China, labor's cheap. So I decided to invite my Chinese friend over to be my cameraman because, as I said prior, he's my friend. Get it? Get it? Because you're thinking something racist.
What?
In the past, scientific researchers have been hot and smart. But today, I'm gonna prove that someone as dumb and ugly as me can also do lab experiments. It's time to break these stereotypical barriers. Hoo-yah! As any good scientific researcher, I need to test that my tools are in working condition. Alright, I think this works. It's kind of hot actually. Oh man. Where's the next one? Okay, right here. Okay, let's see it works. Okay, it works. Oh man, it's so burnt. It's burning. Not even the cleaning it, making it colder. Okay, last one I think. They work. Now that everything's in working condition and set up, it's time to it's time to get started. As shown here in this picture, shining a laser beam onto the CD causes diffraction and in turn creates an interference pattern of bright fringes. Now if we assume that the light began behind the CD, we can see a right triangle where the theta of the right triangle is from the central maximum to the first order fringe. And from there we can use the formula d sine theta equals to m lambda and solve for d, which is the distance between the slits. Let's give it a shot. Ow! Not again! In order to find out the distance between the slits on the CD diffraction gradient, we need to fill in the missing variables. We will use the wavelength written on the laser pointer as lambda. We are measuring the two closest bright fringes, so in that case, we'll let m equal to 1 as the first order. And finally, sine theta can be solved by taking the opposite over the hypotenuse of the right triangle we formed in the image. Using the blue laser pointer, the difference between each slit on the diffraction gradient came out to be 2.964 micrometers. Using the green laser pointer, the difference between each slit on the diffraction gradient came out to be 2.959 micrometers. And finally, using the red laser pointer, the difference between each slit on the diffraction gradient came out to be 3.016 micrometers. On Google, it said that a compact CD usually has a groove distance of about 1.6 micrometers to 4.5 micrometers, and this value falls within that range. I assume that the CDs with smaller groove distances are used to store more data, and those with a larger groove distance are used for commercial purposes, like the ones that I bought. Whew. That was some hard work. So anyways, that's the video for this lab experiment that I had a pleasure doing. It was such a good way to unwind from all the stupid finals that are coming up. Anyways, I have to go hiking soon, so until then, I'll see you guys in the next video. Take care and stay safe.